Hi, good day everyone. So this is the recap video of our second algebra class, which was based on simultaneous equations, factorization by grouping, and finally we touched on some quadratics. Okay, so let's get started. Now, a very important rule that I would like you to remember going forward is when you are dividing or multiplying negative numbers. Okay, so we obviously know that if you multiply a positive number by a positive number, the answer will be positive, right? So we have an example, 5 by 5 is 25. However, if you multiply a positive number by a negative number, say 5 multiplied by negative 5, the answer is always going to be negative. So it's going to be negative 25. Now, if you multiply a negative number by another negative number, the answer becomes positive. So negative 5 by negative 5 equals 25, right? So negative 5 by negative 5, 25. So that's just a couple rules there. So let's move on to simultaneous equations. So this is where we have two things we don't know in one equation. So before we had x plus 5 equals 7, and we know that x would be equal to 2, right? We had one unknown in that situation. However, if you look at this example over here, we have x and y in this one equation, and another x and another y in the other equation. Now, if we only had one equation, we could not find x and y together, okay? However, now that we have two equations with the x and the y, we can actually use the two equations to find the two unknowns, okay? So there are two major methods that we would like to learn about here. The first method is elimination. The second method is substitution. So in elimination, we try to either add or subtract one equation from the other to get rid of one of the unknowns. So for example, see we have 1x here and 1x here. If we were to minus those, they would actually kind of cancel out, right? 1 minus 1 is 0, okay? So we say equation 1 minus equation 2. So the x will subtract from the x and become just x. The 2y will subtract 1y and just have 1 remaining y. And finally, 8 minus 5 is 3. So therefore, we find that y equals 3. Very simple. The next part now is to substitute the y equals 3 into one of the equations above. Anyone will work, right? So wherever you see y in we use the equation 2, okay? So wherever y was in equation 2, if y was here, we now need to put a 3 instead. So we write back the original equation, x plus y equals 5, and then we replace the y by 3, so it becomes x plus 3. Right, x plus 3 equals 5, and then we solve it like a regular algebra. X is equal to 5 minus 3, which is 2. And so we are finished. We found y, we found x equals 2, y equals 3. Okay? And remember, we could have substituted it into any of the equations, right? If we did it in one, we would have gotten the same answer. So let's look at another example here now. 3x minus 2y equals 11. 4x plus 2y equals 10. So in this one, we have a negative 2y here and a positive 2y here. So we actually need to add them together. If we were to minus one equation from the other, minusing negative 2y minus 2y will give us negative 4y. And we would not have gotten rid of these y's, and definitely not the x's as well, because 3x minus 4x will still be negative x. So that would not help us in any way. So we need to try to add the equations together. So negative 2 plus 2 is equal to 0. Okay? Think about it. So that's why we add the two equations. So let's go. So 3 plus 4 equals 7. Negative 2 plus 2 equals 0. And 11 plus 10 equals 21. So now we can go and solve for x. X is equal to 21 over 7, which is 3. Right? So now that we have x is equal to 3, we can substitute it back into one of the equations, and we choose equation 1. We can also choose equation 2. Makes no difference to me. So again, everywhere that we see x now in equation 1, because we solved for x, okay? So if it is 3x, we need to put 3 multiplied by 3, because x is actually equal to 3, minus 2y equals 11. And then we could go ahead and solve for negative 2y, and then we could solve for y. If you're having problems solving for the unknowns, then you should go back into my previous video and look at the basic algebra class, okay? Because this is incorporating things from the basic algebra class to find y. So we come up with our final answer: x is equal to 3, y is equal to minus 1. So now let's look at the second method, substitution. So again, I'll be using similar examples here. So in substitution, we choose one equation, we work with it, and then we have to substitute it into the other equation that we did not use before. Okay, so I'm going to choose equation 2 first. So what you need to do is that you need to choose one of the unknowns from equation 2 and make it the subject of the formula. So I'm going to choose x to be my subject. So x plus y equals 5, x is equal to 5 minus y. Again, if you're confused about the subject of the formula, it's very easy to go back into the basic algebra class where we discussed subject of the formula, alright? Good. Now that I have made x the subject of the formula, I can go and substitute that now into the other equation that I did not use. So I'm going to substitute x is equal to 5 minus y into equation 1. So every time I see an x in equation 1, I need to put 5 minus y instead. So I end up with 5 minus y instead of the x over here, plus 2y equals 8. And then I solve for y as usual. The minus y plus 2y is y. So y equals 8 minus 5, which is 3. Now that I have found exactly what y is, I can go and find what x is now. So I take this same simple subject of the formula here, and I put the y now into it. So it becomes x is equal to 5. Instead of the minus y, we have minus 3, because y is 3. And so x is equal to 5 minus 3, which is 2. And so we found what x is, and we found what y is. Done. Okay, let's take one more example. Here we have another example. So we can choose any equation. Let's choose 1 this time. So from 1, x plus 3y equals 7. And therefore I just choose to make x the subject of the formula. Very simple. X is equal to 7 minus 3y. I move the 3y to the other side, okay? So now I have to substitute the subject of the formula into the other equation I did not know, which is equation 2. So every time I see x in equation 2, I substitute 7 minus 3y instead. So I had 2x into this equation, so I have 2 multiplied by 7 minus 3y, because that's x. And then I add the 5y equals 8. So I expand my brackets. 2 multiplied by 7 is 14. 2 multiplied by minus 3y is minus 6y. Now I can add these two y's together. Minus 6y plus 5y equals minus y. Okay? Think about that for a second. And then I move the 14 over to the right hand side. Plus 14 becomes minus 14. So I get minus y equals minus 6, and I can just take out my minus signs. Y equals 6. Right. So now that I have my y, I can go and substitute back this y into this equation here. So x is now equal to 7 minus 3y. So x is equal to 7 minus 3 multiplied by 6, because y is equal to 6. So 7 minus 18 equals negative 11. So x is equal to negative 11, y is equal to 6. Okay, simultaneous equations are very simple. So you can go back through that how many times you like until you get it correct, okay? So let's move on to factorization. So in the previous class, we talked a little bit about factorization. It was a little introduction, and we said that factorization involves finding what is common amongst terms in an equation, okay? So from 7x plus 7y, obviously, the common thing there is the 7. 7 belongs to both terms. So we can pull out the 7, right? Like this. We pull out the 7 and put what is remaining in brackets. Factorization is just fancy division, okay? whatever you choose to pull out, it means that you are dividing by that. So you are dividing 7x by 7. What do you remain with? X. That's why you put x here. You are also dividing 7y by 7. And what do you remain with? Y. So you put the y there. That's how you get x plus y. Okay, and you have your 7 outside. And to make sure you are correct, you could just go and multiply it back. Remember, 7 will multiply by the x, 7 will also multiply by the y. So it will be 7x plus 7y, which is our original equation. And let's take this other example now. 9b squared minus 3b. Now another important thing you need to know about b squared. B squared merely means b multiplied by b, right? B multiplied by itself, right? This is different from 2b. 2b is 2 multiplied by b, okay? So note that difference, right? Right, so what is common between these two terms now? Yes, the b, we have a b squared here and a b, but there's also something else that is common, and that is the number 3. 3 is common here, and remember 9 can also be divided by 3. Remember, factorization is division, okay? So I can pull out the b and the 3 and combine them together. So 3b could come out, right? So let me divide now by 3b. So 9b squared divided by 3b. The b will cancel with one of the b's here, right? Remember, this is actually b by b. If I remove the squared, right? That's b by b. So b will cancel with one of the b. And I'll be left with 1b here. The 3 will cancel with the 9 3 times, okay? Leaving me with 3b here. Now when I divide 3b by 3b, obviously the entire thing could cancel out into 1. And that leaves me with -1, right? That's how I got my answer there. Okay, now if they give us an expression with a lot of terms, so this has 1, 2, 3, 4 terms, okay? There's nothing that is common between all of them. Okay, now some of them have some things in common, like the 7a and the 14b. They have the number 7 in common, right? 7 can go into 7, 7 can go into 14. But there's no 7s in CA and no 7s in 2CB. But what is common between CA and 2CB? The C's, right? We could actually pull out the C's there as well. So it is possible for us to pair them up. So we could put a little separator here. Okay, so we could focus on these two and then these two at the same time. Okay, so let's factorize them one by one. We said that 7 is common here, so we pull out our 7 and remove the 7 from the 7a, and we divide 14 by 7 to get 2b. Okay, right. Now let's do the other side. What is common here? The c. So let's pull out the c. So instead of ca, we will get a, and instead of 2cb, when we divide, we'll take out the c there and get 2b. Now if you realize something, the two brackets are exactly the same, and anytime we are factorizing by grouping, this means we are grouping them, right? The brackets need to be the same. You cannot have different brackets here. So the final answer, we use one of the brackets here, a plus 2b, we write it back into our final answer, but we have a second bracket, and where does the second bracket come from? We combine this number and we combine this number, including the sign, okay? So the second bracket will involve the 7 and the plus c, and this is the factorized form of this big thing here, okay? Now an easy way to check that back over, we can simply multiply the two brackets. And how do we do that? Well, we can treat the first bracket as the master bracket, okay? So each of these terms, the a and the 2b, needs to multiply by the second bracket. So this is how it goes. A multiplied by 7, a multiplied by c, 2b multiplied by 7, 2b multiplied by c. So if we multiply a by 7, what do we get? 7a. If we multiply a by c, what do we get? AC or CA. I'm going to write CA. It doesn't matter if it's AC or CA. 2b multiplied by 7 is 14b. The 2 by 7 is 14, and the b will multiply to be just b, right? And finally, 2b by c is 2cb. Right? When you're multiplying letters, you just put them together, okay? And isn't this the same as the original equation? Remember, we could arrange them differently, it doesn't matter. Okay, so you have 7a, you have the CA, you have the 14b, and you have the 2CB, and that's how we know we are correct. Okay, but we don't need to do that all the time, right? If you are confident in yourself, you don't have to go and multiply it back and waste time. Okay, once you are confident in your method, that's fine. Let's take another example. Example 2. 6x plus 9 plus 2kx plus 3k. Again, we can see that there's something in common between here. A 3 could go into 6 and a 3 could go into 9. And over here we have the k and the k being common. Okay, so we pairing them up again. So we pull out the 3, and 3 could go into 6 2 times, so we are left with 2x. 3 could go into 9 3 times, so we are left with the 3. K can go into 2kx, the k's will cancel, we will be left with 2x. K can go into 3k, the k's will cancel, we will be left with 3. And so for our final answer, we used one of our brackets to make 2x plus 3, and we combine this number and this letter to get 3 plus k. And that is our final answer. One more time. As you can see, yes, there's a m here, and a m here, but remember, there's no m here. So we already know that we need to factorize by grouping. If there was a m here, we could have simply factorized by using the common one, right? We could put out m in all of them and create one big bracket, but we can't do that. So we are forced to use pairs. So again, let's pull out the m here because that's what's common between them. Remember, this is m squared, right? So anytime you divide by m squared, this is m multiplied by m, right? So when you divide by m, you can only take out one m at a time. So dividing by m will just net you 1m. So we have our m here, and negative 2m divided by m, the m's will cancel, you will get negative 2. Now remember, we need to get negative the same bracket here, m minus 2. Okay, so we need to actually take out minus n, and let me show you why. If we had took out plus n, we would have been dividing negative mn by n. Yes, the n's would cancel, but we would be left with negative m. And this is already different from our first one here. This is positive n, and this is negative m, so it's not the same. So we definitely need to divide by negative n. So the n's will cancel, and also the negatives will cancel to give us our positive m. In the same way, we have 2n now divided by negative n, right? Remember, this is actually supposed to be negative n. So the n's will cancel, and anytime you're dividing by a negative number, remember in our first rule up on top, the answer will always be negative. So that's how we get our negative 2 to get back into our brackets. So we have to factorize by negative n. That's very, very important, okay? So you need to keep watching that. And so our final answer, the m minus 2, put back that in brackets. We take the m, we take the minus n, we put that into its own bracket, we get m minus n. Okay? And finally, we move on to quadratics. So quadratics are any expressions or any equations that involve a x squared, right? So all the algebra we have been doing was just x so far. Now we have x squared, right? And quadratics, we usually have two answers most of the time. And you know why? It's because if you have a square number like 25, right? We know that 5 multiplied by 5 will give us 25. But again, if we look at our top 3 rules, we know that a negative number multiplied by a negative number will also give a positive number. So if negative 5 multiplied by negative 5 will also give us 25. Okay, so if 25 is a square number, what was the numbers that made up the 25? It could either be 5 multiplied by 5 or negative 5 multiplied by negative 5, okay? That's why quadratics usually have two answers, okay? So we actually solve quadratic equations by factorizing, okay? Very similar to the factorizing that we did up there, all right? So let's take this equation, for example, here, okay? we need to factorize this into two brackets, right? So all I do is that I write down these two brackets like this. Blank brackets first. What do I put in my first two spaces here? This space needs to multiply by this space to get this value. Okay, the first by the first equals the first. Okay, so we obviously need an x here and an x here because we have x squared. X squared is x by x, right? So that's why we can write x and x in our first brackets. Also, the last by the last equals the last. So the last number here in this bracket and the last number here in this bracket will equal the last number in the equation. So what can equal 6? Well, we can have 6 by 1 equals 6. We could have 3 by 2, that also equals 6. Or remember our rule, negative 6 by negative 1 could equal 6. Or negative 3 by negative 2 will equal to 6 as well. But which one of these is correct? Only one of them is correct. Well, it depends on this middle number. So the numbers that we choose that multiply to become 6 also need to add. When we add them, they become 5. Okay? So let's, instead of multiplying, add them together. So let's add 6 plus 1 and 3 plus 2. 6 plus 1 is 7. 7 is definitely not equal to 5, so this is wrong. 3 plus 2 is equal to 5. Aha. So we already know that this is the answer. Just to be clear, let's add the rest of them. Negative 6 plus negative 1 is really just negative 6 minus 1. When you add in a negative number, you essentially minus it. Okay? So this is negative 7, which is definitely not 5. Negative 3 plus negative 2 is negative 5. Now I have a 5 here, but this is negative 5. We have plus 5. Okay? So, therefore, the answers that we put in the brackets are 3 and 2. And we can put any one of them there. Okay? The next step, I'm going to erase this so it could be a little more clear. You could go back to it if you want to get that working again. The next step now is to now solve for x. So we separate each bracket now and make it equal to 0. So this becomes x plus 2 from this bracket equals 0. And then x plus 3 equals 0 from this bracket. And then we can easily solve for x. X is equal to minus 2. X is equal to minus 3. That's from algebra, okay? And here I proceeded to work it out to color code it for you. That shows you that the blue by the blue equals the blue. The black by the black equals the black. And you know you have to plus the two blacks to get a red, okay? I tried to color code it there, so hopefully it could help you understand a little better. Right? Okay, let's take a second example now. X squared minus 5x minus 28. Right? So again, our first step is to write these two brackets down blankly. And then we need to use our first by our first to get our first. Our first is x squared, so always it's x and x goes into the first spot in the bracket, right? Now let's take a look at negative 28. We need to find two numbers that give us negative 28. So let's write down some of them. Remember, it's a negative number, okay? So we could have different possibilities. It could be 28 by negative 1. That gives us negative 28. Or it could be negative 28 multiplied by 1. That also gives us negative 28. It could be 14 multiplied by negative 2, or negative 14 multiplied by 2, or it could be 7 multiplied by 4 by negative 4, or negative 7 multiplied by 4. All of those give us negative 28. However, we need to find the correct one that gives us minus 5 when we add them together. So let's do that now. Instead of multiplication, we are going to add these together. So you're going to put addition signs here instead. Okay. So 28 plus minus 1 is really 27. That's definitely not negative 5. Minus 28 plus 1 equals minus 27. Wrong again. 14 plus minus 2 is really just 14 minus 2, which is 12. That's wrong. Minus 14 plus 2 is negative 12. That's also wrong. 7 plus minus 4 is really 7 minus 4, which is equal to 3. And minus 7 plus 4 is equal to negative 3. So I actually made a mistake in this question, guys. It's actually supposed to be a negative 3 here. That was a mistake on my part, okay? If I had 5 here, negative 5, it will never work out, okay? So it clearly needs to be, instead of negative 5, it needs to be negative 3. That was a mistake on my part, okay? I apologize for that, but this is the correct answer. I hope you guys understand the mistake and understand what really went on here, okay? We can't actually get negative 5 from 20. That was just a mistake for me. Okay, so this is my correct answer, negative 7 and 4. So I put my negative 7 here, I put my 4 here, and then I proceed to solve it. So x minus 7 is 0, x is equal to 7, x plus 4 is 0, x is equal to negative 4. And we have solved it just like that. Okay, let's take one final example. Actually, we have a couple more examples. X squared plus 3x minus 18 is equal to 0. So I left it blank so we could fill it out, right? So x again by x will give us our x squared. Now we know this one by heart, right? So we could easily just put that. The hard part is getting the minus 18, and the ones that correspond to the plus 3. So again, let's write it down, right? So minus 18 by 1, or 18 by minus 1. It could be 9 by minus 2, or minus 9 by 2. Anything else? It could be 6 by minus 3, or minus 6 by 3. That is our possibilities for negative 18. Which of these add up to give 3? Obviously, it's not 18 and 1 and 18 and 1, right? So let's add 9 and minus 2, we will get 7. 9 minus 9 plus 2, we'll get minus 7. I'm not changing the signs, right? Just to keep it quick. And finally, 6 plus minus 3 is really 6 minus 3, which is 3. Aha. So we already got that there. And then, well, for completion's sake, minus 6 plus 3 is actually minus 3. So that's wrong as well, right? So the answer here, we need to put a 6 and a minus 3. It doesn't matter in this case if you put the 6 on the first bracket or the 3 on the second bracket, right? It does not matter. And then again, we solve like a regular algebra equation. X minus 3 is 0, x is equal to 3, x plus 6 is 0, x is equal to minus 6. Very simple. And finally, I actually did the work in here for the last question, right? Nice and neat for you guys. So you guys could actually work this out yourself. I just changed the plus 3 to a negative 3, and therefore the answers would be a little different, right? Instead of the 6, we'd have negative 6. Instead of the minus 3, we'd have positive 3. So we just flip them around if we change the middle number, okay? So I actually worked this out for you. And really, that's all there is to the simple quadratics and factorizations and stuff like that. So I hope you guys look at the video. You could go through it how many times you would like. If you have any problems, you can feel free to message me and I could explain it further for you. Alright, so in our next class, we'll go more in-depth into quadratics and more in-depth into factorization and using our factorization formula as well, okay? So thank you for listening, everyone.